Hi guys, good afternoon. Can you hear me? Just give me quick confirmation so we can go ahead. All right. I assume my screen is also visible to everyone, right? And yeah, okay, guys. So let's get started today. Today is our last day, guys. Again, welcome back to this last day of the series. And I hope you guys have enjoyed till now all the sessions which I've concluded and found it very helpful for your skill steps. Okay. And today is the last day, so we're gonna make it very let's say very exciting, because today we'll be talking mostly about the, let's say, the top topics of the town in the AI or state of art algorithm. That is, what is generative AI, what is this chat GPT, how the chat GPT is trained, and what are the feature, what are the model which are used behind this, what is LLM, what is prompt engineering. All this stuff we'll talk about, and probably if time permits, I will take you through one of the base model for this large language model, how these models are trained, and I will make a code walkthrough very quickly. I will not try to run everything, but I will try to show you at least in the background what are the codes that are written and how these things are working, what are the base model and everything. All right. So I hope everyone is very much excited, and let's get started with this amazing session today. So because this is the state of art technology nowadays, and nowadays prompt engineering has become very hot topic out there in the US or anywhere in the Europe or even in the India. So everyone wants to become a prompt engineer. So let's understand what is this prompt engineering, what is this generative AI, how it is different from normal AI, and everything, right? So before even we go into this generative AI, I would like to tell you guys that there's one more topic which we were not able to cover, and that was the topic of the let's say transfer learning, right? What is the transfer learning? Everything. Maybe I would like to go through very quickly that what is transfer learning, and I'll try to give you a very quick overview about the transfer learning, what transfer learning actually means, and then maybe we'll start with the generative AI. So let me go back to the transfer learning. All right. So guys, just quickly give me a heads up that whether you are able to see this transfer learning slides. So within like 10 minutes or 15 minutes, we'll try to finish this one transfer learning. This is also a very important topic, super important topic. So you should be aware of this topic. All right. So I guess everyone can see this, right? All right. What I'm saying is, guys, what I am trying to say is today we're going to focus mainly on the generative AI. What is generative AI? What is large language model? What is prompt engineering, right? And before that, within 10 minutes, I want to finish this transfer learning, correct? So transfer learning is one of the important topic in the deep learning arena, and everyone nowadays is using the transfer learning. Whatever model CNN, RNN, or artificial neural network we have seen, all these models has to be generated from the scratch, right? That was the bigger challenge, and even we need to make the fine tuning. We have to take all the pain how to create this one, whether it will work or not. For that purpose, this concept of the transfer learning comes into the picture, right? Nowadays, no one is creating from the scratch all the architectures or all the models. Like I told you about the history of the CNNs, where in 1998 first network was introduced by the Jan LeCun, called as LeNet. Then there was a AlexNet, which was introduced by the godfather of AI, right? The godfather of AI, Jeffrey Hilton. And then all the series of this CNN state of art model started. Even for a normal person, it is difficult to train this kind of model, because it is trained on huge amount of images, right? Like we saw 10,000, 20,000 images we were trying to give it. And then on the basis of that, we are able to make the training, right? And we require a special kind of hardware for that purpose, and for everyday life it is not possible. Obviously, if you are working in the corporate, then it is possible. You are trying to procure the GPU. Even for the GPUs which are procured in the corporate, right, if you want to train it or achieve higher amount of accuracy, it also require very high end semiconductors, or let's say GPUs, all this part, and that is really difficult. For that purpose, this transfer learning coming into the picture, right? I understand what do you mean by transfer learning. people already created the structure and it is tested and trained on the huge data set which is available. So what I can do is I can use this kind of architecture which is already tested or trained, and I can again try to retrain it for my own data, right? This is also possible. The basic task, let's say I am doing a computer vision task. So in that computer vision task, we already understood what are the tasks. If I want to make an image classification, or I want to make the segmentation, right? Segmentation, or maybe I want to make a detection, right? Object detection, or maybe I want to make the tracking, right? So this kind of task, track any images, live feeds, cameras, videos, everything, right? Whatever I am feeding it to it, so videos, let it be videos or the images. I want to track a person, track a car, or track entire scenarios. That kind of use cases we have seen in the computer vision. And for that purpose and for accuracy purpose, we need to generate a huge amount of data. And the main question behind this deep learning models is how you gonna generate the data. One technique is maybe you make a data augmentation technique, where you are having certain amount of data in terms of videos and images. You try to duplicate them, make them augmented data set by using tilting the images in some direction, anti-clockwise, clockwise, 45 degrees, something like that. Still, you require huge amount of data, which will be like in thousands or millions of data. At that time, and even that kind of hardware, at that time you will be able to achieve highest accuracy. But just to solve this kind of things, they have come up with the technique called as transfer learning, where all the architecture and everything is taken care by the people, and they have published a paper. Even they have benchmarked, right? They have benchmarked models on the basis of certain standard data sets. Okay, standard data sets are there, like just like the COCO data set, MS COCO, ImageNet data set, MS COCO, ImageNet data set. All right, ImageNet data set is there. Even the CFAR data set is there. Canadian Institute for Research or something, CFAR. Okay, CFAR data set, and there are other data sets as well. And where these guys have introduced or trained their model, and also published that what was the accuracy they were able to achieve. Whenever you will try to go back to the new research paper for all the respective models, at that time you will be able to go through the research paper, and at that time you will understand that what kind of parameters are used, what kind of layers are used, and on what basis and how much data it is trained, and what is the result it is achieving across the different data sets. So why to take all the pains if these guys have already created such model, right? So maybe we can use the make of such models, and we try to customize them, right? Try to customize these models as per our needs. So then our problem can be solved, and we can apply it, right? We can apply it to solve our business case. So that was the basic idea why this transfer learning is important. And again, what we are trying to achieve, if you talk it from the neural network side, we are trying to achieve the weights and biases, right? For what weights and biases my model will be able to perform using the backpropagation. If I get an entire file of weights and biases on which the model is saved, I can directly use this weights and bias, and I can further train it on certain other tasks, right? And I can use it for my own purpose. That is the entire intuition why this transfer learning came into the picture, or why we should go for the transfer learning. So let's try and understand. As per the definition, transfer of learning means we are trying to apply certain skill or knowledges to, or we are trying to transfer these skills and knowledge to some other people, right? From one people to people, generation to generation. So this concept was lately introduced into the 1992, but it is still going on. So what if, like, let's say I try to take a example of this dog cat classifier, right? So we already created dog cat classifier, or maybe that dog cat classifier will not be able to classify elephant and tiger, right? Or if I give any cartoon images, it will not be able to do. But at least if you try to figure out whether there is an image present or not, or up to certain accuracy, it will try to classify the things, right? So that could be also possible. So what we can do is we can use this pre-trained model, which are at least used for the binary classification, or maybe used for the multi-class classification, and we can again retrain them Not all the entire layers, but up to certain layers, we can retrain them and we can use it for our purpose, right? So that is the biggest thing they are trying to achieve over here in the transfer learning. I will not go into detail, guys, everything that what is happening and how is happening. I have made it very self-explanatory in this task, in these slides, coming slides. So maybe I will just try to take over you because the today's topic is generative AI and requires certain amount of concentration, right? So let's go through them quickly, and I will also try to tell you what is transfer learning in the meanwhile. So let's say my model, why we need this kind of techniques, right? Chat GPT, yes, guys, I will try to tell you how the Chat GPT is trained, right? I will tell you the entire process how the Chat GPT is trained in first place. That is also an important topic for today. Let's understand that why these things are required or why we need this kind of transfer learning. So what it says is, let's say I have a model which is able to detect the object, right? Able to detect the object, and these objects are related to food items, right? Let's say food item. This is kind of, let's say this is a kind of model which I have implemented back in the corporate where we were working for the healthcare company. At that time, what was the use case for them is user clicks his picture of the plate, whatever he is eating, and that picture has to be uploaded to a healthcare application, right? So once it is uploaded, that model behind it, food detection model, food model will be able to analyze what is there in the plate, and on the basis of that, it will be able to categorize, right? What are the items present in the plate, and the basis of that, it will try to categorize how many calories you are taking. Let's say if in this situation, let's say my model is basically trained on the object detection model, right? Object detection model, and it is able to identify the object which are related to the food. So when I click my picture of the plate, and that time when I pass this one to my model, if looking at the picture, it will be able to say that in first picture there is a meat, right? In second picture there is salad, and third picture it is pizza, right? And the basis of that, if I am able to identify the objects, I can associate the calories, respective calories, right? Meat will be having higher calories, salad will be having lower calories. Again, the pizza is junk food, it will be again having higher calories. And even I know the approximate estimation, let's say meat will be having around 500 to 800 calories, right? Let me clarify everything. So meat will be having maybe 500 calories. If I eat in certain proportion, again the salad will be having very low calorie, like say up to 100 and 150. And again the pizza will be having around 500 calories, right? So if I sum it up, then I will be almost taking 950 calories. And on the basis of this, I will be able to make a calculation if I am on weight loss plan, right? If I am on weight loss plan, or at least I will be able to understand that how is my food intake and how much calories I need to burn, right? Burning the calories. And this kind of suggestions can be given directly by the app. If you try to click only a single picture of your plate and try to upload, let it be lunch or dinner, so it will be able to identify. So this could be an amazing use case where you can use this kind of models which are already pre-trained. And what will be the challenge and why we'll need a pre-trained models, and how we can customize, like try to understand these things. Let's say this model is created by the US people, right? Back in the States. So US people will not be eating the food the way Indian people are eating or the Asian people are eating, right? Asian people are usually eating pakodas, right? Samosas, bhel, or let's say our customized rice, right? Or many culinaries are available right from south to east, and even in the western region. So there is a different region, different cultures are available, different culinaries are available, right? The different culinary cultures are available. So at this model will not be able to identify those items, because if I am living in India or Asia and I'm trying to provide the picture of my plate, obviously it will fail, right? So, but at the base end, it will be able to understand what is bread, right? What is the bread, what is salad, what is vegetable, what is non-vegetarian food, right? That kind of items at least is prepared. So I can utilize that knowledge, and I can try to retrain this model. So I can save the entire time for training from the scratch, right? So that is the example, right? What I can do is, rather than training, if a training requires, let's say 500 hours for such a huge data set, rather than going for the 500 GPU hours, I will try to use this model which is already pre-trained on the object detection, right? and I will try to use certain layers, up to certain layers of this let's say convolution neural network, which is used for the object detection. And then I can again retrain it on the Asian food, right? On the Asian foods or some of the food categories. These categories may be equal to some 100 categories. So whatever my basic model is trained, it is trained on the, let's say, 10,000 categories of the different food, but these 100 categories were not present, right? So what I can do is, rather than training from the scratch again for all the categories, I can utilize this knowledge which is available for these 10,000 categories, and I can add this, right, 100 categories to it. So that kind of adjustment or that kind of learning is done in the transfer learning models, right? So I can customize for my own model, my own food product, and then I will be able to identify the calories. I will be able to even classify whether you're taking healthy food or not unhealthy food, right? So that kind of things. Even same could be going for the spam classification or not spam classification. You can even further categorize it for your own purpose. Let's say even out of the spam, you can categorize as an advertisement or social media advertisement, marketing people, or some other category, right? That could be also possible. So that's why I have given this two example. I guess now people, you will be able to understand that why we need a transfer learning, or what do you mean by transfer learning, right? By giving this kind of real-time example. But then this is also possible for various use cases, not only for object classification, but also for object tracking, right? Let's say there is a model which is trained to how to detect the human face, right? So that model you can customize for your own purpose, and maybe you will be able to implement for your corporate reason, right? For security reason, surveillance reason, or maybe very beautiful use case which has been recently used is for attendance management system, right? I will tell you what is the use case. Whenever a person enters into the campus, right? So at that time, he will be detected. Let's say he is a Vikas. Vikas will be detected through the surveillance camera. In the surveillance camera, this kind of camera, whenever he try to enter into the campus, first time, let's say in 8 o'clock or somewhere, first entry, he will be detected and the time will be noted. Let's say time is 8 o'clock, 8 in the morning, 8 a.m. Vikas entered the campus of the college, right? So it will take this record. I'll try to store it in the log file. Okay. We'll try to store it in the log file, this kind of log file, and it will again try to, whenever I will be moving throughout the campuses, there will be different cameras available, and everywhere I will be getting tracked, right? So I will also have a simultaneously feeds of my appearances and of my object detection, and this log file will be covering all the timelines, right? Let's say all the timelines and the persons who are detected. So this way, people will be tracked using the camera, and in the background there will be model running, which is a face detector or human detector, and it is feeded or trained on the entire students, whatever students are there in the colleges. For that entire students' faces, it is trained. So this way will not require any monitoring. Even through the security camera, we will be able to monitor. Even you will be able to monitor that when was the first entry made by this person, and also since we are tracking him simultaneously, he's going through entire cameras, we will be able to track what was the last exit he made. So this way we can track that how, for what amount of time this person was present in the campus and when was the last exit for this one. So if I calculate the first entry point and try to minus this timeline from the last entry, I will obviously getting the time he has spent into the entire campus. The similar thing also implemented in the corporate sector, that whenever people try to enter into the floor, and then whenever they try to exit and again come back, this way automatically through the camera, their production hours will be tracked, right? And then you will not be able to give an excuse to your manager that, okay, I was working for 8 hours, still I was not able to complete this task, right? Even for school purpose, college purpose also, we don't need any attendance system going forward. Easily we can apply this kind of face detection model through our surveillance cameras, which are already present everywhere, and in the background it will be creating log for entire student, right? This is the real-time use case which has been implemented. So what we have to do is, we have to just use the model which is already trained, face detection model. Just try to retain this model on your campus college student data, right? So you no need to train entire things from the scratch. So that could be a great example. Understood, guys? Now just try to ping me whether you guys understood what is the entire funda between the transfer learning and why we need the transfer learning. What is the use of this transfer learning? Using the transfer learning, we'll be able to achieve the timelines. Also, the entire headache of the pain of the training the entire model from the scratch will be avoided, and we can use these models weights to customize for our own purpose. That is the sole purpose for this transfer learning. Clear, guys? Just ping me quickly if you are able to understand. Then I can go and slide through the other slides. All right. So motivation we again spoke, right? You will be not able to understand entire things again. Just for one simple task, how much time will be required, or how many GPU hours will require, and how much calculation is happening, right? So even for analyzing whether this is a spam or not spam, image recognition, or how many videos coming into the YouTubes every day, so you'll not be able to train these many models. So that is how you can use these pre-trained models. Is it using pre-trained model to implement on different data set? No. They are not using pre-trained, or maybe they are using. See, whenever people come up with a new architecture, they try to train the models entirely from the scratch. Let's try to understand these things. The companies like Google, Facebook, Meta, or whatever the big shot companies are there in the AI, they try to publish the papers, right? They try to publish the papers, or they try to come up with the different models. Through publishing the paper, they are able to show that they have developed this kind of model. At that time, they are not using any pre-trained models, right? They are trying to create the entire thing from the scratch, right? So what happens is once these people or big shot AI companies or researchers, right? These researchers publish their papers, people use these papers and try to implement their own customized models. So at that time, it will become transfer learning. So that's what the difference is. First time, they will try to publish the research papers, big companies, this researcher, ML researcher, and then they will be showing at a certain data set it has been trained, and they will be making you available through the APIs and through the implementation through the GitHub and some other portals. So you can use their model. They maybe use this model for certain purpose. So you can again go back and train this model on the different use cases. So that's how the things will happen. Website for this, you can use it like there is a website called as, there are several websites for Google and Facebook and for TFOD. One of the website is like Teachable Machine, writing research paper. Yeah, research paper is everything available. You try to search in the Google. So there are different sites where there are special site like ARIX, something called that kind of sites are there. They are specially they are uploading the research paper related to machine learning. Also, there is a site called as Trainable Machine, Teachable or Trainable Machine. Okay, Trainable or Teachable Machine. Try to search it. Where Google is providing all their pre-trained models, right? All the transfer learning models. You can customize these models. Even you can train these models for your own data on that website only. You can train your models on that website only. Teachable or Teachable Machine, something like that. You try to search Teachable Machine, and you will be able to get this kind of website. Also on the GitHub, okay, if you guys are already aware what is GitHub, right? It is the CI/CD tool, GitHub, where everyone is trying to save their repos and code, right? Mostly corporates use it, code saving, right? For saving the code, they are using these GitHub links. In the GitHubs, there are open repositories. Yeah, Teachable Machine, correct, guys. Teachable Machine with google.com. So these kind of sites are available. This is not the only site. There are various sites where they are offering these kinds. Even the PyTorch. If you go to the PyTorch site, PyTorch is one more framework, right? For the machine learning. PyTorch is the framework. What was the first one? Teachable Machine, guys. Teachable Machine. I'll try to, someone has pinged me. I'll try to post it in the common chat box. Teachable machines. Dot with Google, right? That sort of things is there. Teachable Machine with Google. So you can search it, you will be able to get it directly, right? So that is not the only thing. Even there are various other options are available. Let's say, whenever I told you guys that these are the popular framework, let's say TensorFlow, PyTorch, Keras, you can go to their official website. On that official website also, they have this pre-trained model available. You can directly use from there. Also from GitHub, from Kaggle also, there are people are hosting different services. You can go to this kind of things and you try to achieve this pre-trained model, and you can train them. Even they will be telling you the entire things that how to train with the instruction set. So what we do is usually try to understand quickly. So what we do is we try to take the data set. We take the data set and we try to teach the different model to perform different things. But in the transfer learning, what happens is the model is already trained, and we are trying to retrain that model again on certain data, and then try to achieve certain specific tasks. So that is the basic difference what we are doing here. Let's move to the next thing. These are certain learning techniques. Okay, so I'll not go into details. Neural network layer specific to general. Let's say what happening is in the transfer learning overview, right? This is the input one is given to a bigger model, right? And that model is trained on task A. Again, that model will be taken, and again different model. We try to freeze the weights. I try to understand the concept. What do you mean by freeze the weight? So if this entire model is trained, right, and this entire model, let's say convolution model. So this convolution model will be having convolution layers plus the artificial neural network layers, right? We understood it is made up of both the layers. So up to certain convolution layer, neural network layers, it will be 10 means it will be able to extract the features, right? So all this model will be captured, right? Let me use the different color. So what is happening is the part which I am trying to show you through the red color. Till this here, there is a convolution neural network. And after that, there is a feed forward network, that is normal neural network, right? Which is able to predict and give us the prediction, right? So what we usually do is in the transfer learning, this model which was trained earlier, right? It went through convolution layer, pooling layer, padding layer, everything, and it is able to extract the features, right? It is able to extract the feature. It is trained on how to extract the feature. So what I can do is I can take up to these layers and I try to freeze the weights. And then after freezing the weights, I will try to add new layers of the convolution with the combination of my input data. And then there will be a forward progression, backward progression. And then with the help of the new data, which I have given to this earlier model, this earlier model is coming from the pink colors, right? I am trying to take the weights for these layers. And then the blue layer is my new layers, which I have created. And using the combination of the already trained model and my trained model, again with the new input data, it will be able to perform task B. That's how the things will happen. And it is called as, can we use this used to classify? Yeah, you can use it for any purpose, computer vision purpose, right? For any computer vision purpose, even for any other purpose where the computer vision is worked, or any deep learning model, you can use the transfer learning for all the tasks, provided that there is a model available, right? Transfer learning model is available. You can use it for any task. So that is the main concept, guys, how the things are happening. So what we're doing is usually the model is trained on certain tasks. We try to take only part of that task and try to freeze their weights, and we'll make a combination with our own new network and new data, and then it will be able to perform other tasks out of it. So let's quickly go through the next thing. So this is the architecture which I have pasted, guys, for your reference. Maybe you will be able to go through it and try to understand it. We will have to make changes in the input number nodes and output. Yes. We will have to make the changes according to the features. It will not affect any neural networks. You can even customize this. You will try to understand. You can whenever you try to look at the code, at that time you'll understand that's not a big task. You will have all these layers and tasks, everything implementation available with you guys. Okay. Now let's try to understand how the architecture will look like if I am going to retrain the model. Let's say this blue model are up to these layers, right? These are the convolution block 1, 2, 3, 4, 5. And then what we can do is we can freeze the weight up to certain layers. Freezing the weight means whatever it is trained upon, we can directly take the weight files there will be weight files, and we can try to, this is how the model will look there. There will be convolution blocks, right? Convolution 2D, max pooling, again convolution 2D, max pooling, padding layer in between. And that's how the things will work. And then what we can do is, rather than taking all the 5 blocks, we can take up to 4 blocks, and then we can fine tune it for our own data. And there will be, obviously, last layer will be for feed forward. So you can use different feed forward. In between feed forward and convolution, what is a layer there? You can use your own layers. Okay. Entire documentation I have given, guys. So maybe you, whenever you get a time, you can go through it. This is beautifully created, line by line, rate by rate, everything is created. What is written, how we transfer the model, what is the different approaches and everything, and why there is a high is when to use transfer learning model, right? That is also I have given. When to use all these things we have discussed, when to use, because we cannot start a model right from the scratch, right? Every time. So how you will be able to train the model for this huge kind of a data, right? Huge images and huge videos, and the time it will require will be very used. So obviously that for that purpose only, we use the transfer learning. I think this is pretty clear, right? Pretty straightforward, that what we are trying to achieve over here, right? In terms of the code, that will not be a difference, right? We have seen the code. If you could remember, we have seen the code. This kind of code we have seen already in the Google Colab, right? Where we are trying to create, we first model equal to, we created model equal to convolution, this function, sorry, not convolution, sequential, sorry. So model equal to sequential, this is what we created in first place. Model equal to sequential, this is the function, high level Keras function we are using. And once we are able to use this, we are just using model.add, right? Model.add. And whenever I am saying model.add, at that time, this is referencing to these blocks, right? I will be using like con 2D, convolution 2D, then, right? Max pooling, right? Max pooling again 2D. This kind of blocks we were able to write yesterday, and we have seen how to create this kind of blocks, right? So that is the code they're talking about over here. And at that time, the last block which you will try to create, you will provide your own architecture. Maybe you try to give a data in such a way that it will be able to perform other tasks as well, along with the predefined task which it is trained. Okay. I hope, guys, this is very straightforward and you are able to understand that what is transfer learning. It is like already trained model. You try to use it for your own data and try to retrain it. You don't have to retrain right from the beginning. You can retrain up after certain amount of layers, right? So for that purpose, there is simple 2-liner code where you can freeze the weights and you can start retraining the model. Now, and since we already gone through the code and everything, how to create our own architecture, right? So you will be able to understand that will not a difficult task. Just guys, quickly ping me that you are okay with this one, so we can start our topic for the day. Yes, no, or difficult, you are not able to understand what is transfer learning. It's okay, right? You can go ahead then. All right, guys. So now coming back to our very hot topic. So what is generative AI, right? What is generative AI? Why there is so much buzz going on? And what do you mean by generative AI? What do you mean by prompt engineering? Let's try to get into the details. Okay. So nowadays, everyone, even a small kid who school going kid, is now talking about ChatGPT, right? He's talking about ChatGPT. The people are talking about Gen AI and various things nowadays. Everyone is able to say, right? Because it is making amazing jobs, right? And even people are trying to say that in coming future, all the jobs will be taken by the robots, right? Or by the AI. So why this is happening, or what kind of tasks they are trying to perform, how it is different from the normal AI, that we'll try to take it. Yeah, guys, we'll try to understand what is ChatGPT also, and whether it is related to Google or something. That things we'll try to understand meanwhile. So ChatGPT nowadays even able to create a code also, right? So all of the well, engineers, right? Software developers, they are now thinking that if the chat GPT is trying to create my code, what will be the future of my job, right? So that is not the thing that what is happening over here, guys. So they have introduced this generative AI because you can increase your productivity. For that purpose only, they have introduced this thing. Even there is a discussion going on that who will be taking the responsibility for this kind of task, right? So we understood that if you have created a self-learning or self-driving car, and if it meet with accident, then who will be responsible? Driver or the person who's sitting in the car? Because there is no driver, right? The person who is sitting in the car, the passenger, or the company who has manufactured it, or the AI company which has provided the software. So who will be responsible, right? And if the chat GPT thing where you are able to provide the prompt, on the basis of the prompt, it is able to generate something. At that time, it goes back and generate anything which is not, let's say, which is not up to a relevant certain ethical standard. So who will be responsible, right? So that kind of discussion is also going on. Let's try to understand about the things that what is AI, what is generative AI, how it is related to the AI. Everything we'll try to understand quickly. So you will say that we have already understood what is machine learning, what is deep learning. Now we'll try to understand where this generative AI and the LLM is trying to fit, right? Generative AI, again, it is a sub part of the deep learning. And in fact, deep learning is a part of the machine learning. And all these things are entire the part of the artificial intelligence. These things we have learned. So whenever we try to talk about these things, whenever we are trying to talk about the generative AI or LLM, so you will be able to understand that we are talking about the deep learning, which is a subset of ML, and in fact, which is a subset of AI, right? So that is a generative AI, right? It is nothing but it is a part of the deep learning only. And generative, and what is large language model? I'll tell you what is large language model. It is the base models. Okay, it is the base models or the architectures on which this generative AI is working. All the applications, right? All the application like Chat GPT, Google Bard, DAL-E, okay, might have heard about the Mid Journey. All these things, or maybe diffusion models, right? All these kind of models, they are using LLM, large language models. So you will again ask what you are now able to at least figure out, right? So where the generative AI and the large language model belongs to, right? It is a part of the deep learning. So now let's go ahead and try to understand that what is the relationship and how they are different from the normal artificial intelligence, right? Let me clarify first everything. Whenever we are talking about the deep learning techniques, at that time there will be two kind of techniques. One is discriminative AI and another one is generative AI. Okay. What is discriminative AI? I will tell you in meanwhile. Okay. So let's try to understand that what are the techniques and what are the models used in it. Whenever we are speaking about the generative AI, at that time I told you that there is a LLM models, right? Large language models which are working upon it. But what are these large language models? These large language model are nothing but the GAN model, generative adversarial neural networks, and the auto encoder and decoders. So this auto encoder or decoder also called as transformers. Transformers, right? You might have heard the transformers. So transformer is nothing but architecture of encoder and decoder. We'll try to go into the detail that what is the GAN model, how the architecture look like, and what is transformer. Transformer is a combination of the encoder and decoder. So what is encoder decoder? Again, it is nothing but the layers, different layers or different blocks of the convolution layers along with the neural network layers, feed forward networks, right? So there will be more different blocks which will be available. One block will be called an encoder, right? And different similar block will be there, which will be called as decoder. And what is this block? Nothing but the different layers of convolution and also the different layers of artificial neural network, right? And most probably they are based on the recurrent neural network sometimes because they're trying to solve the use cases of the NLP. At that time, they are using recurrent neural network as well in the background. Okay, so whenever we are talking about the generative AI models, there will be base models. One will be generative adversarial neural network, GAN, and then second will be autoencoder and decoder, which is a part of the transformer. So again, they are based on nothing but a CNN and RNN. And in discriminative AI, the model like convolution neural network, again also use of the recurrent neural network. So, but you are saying that even both the parts they are trying to use the same network, then what is the difference? Let's try understanding this way. When we are talking about the discriminative AI, at that time we are using the computer vision technique, right? To discriminate, try to understand from the word only, guys. Discriminative technique means we're trying to discriminate, means we're trying to, our generative AI model considered under the unsupervised learning category. Yes, yes, they are always considered under the some sort of unsupervision and some sort of supervision. Because when we'll go into the model, at that time you guys will understand it's a mixed approach. Okay. So discriminative AI means whether we are using any computer vision technique for the image classification. Discriminative means we're trying to discriminate something. We're trying to discriminate something, right? That is discriminative AI. So what we're trying to discriminate in computer vision means image classification, right? So that we are trying to discriminate one image from other. Object detection. Also, we are trying to discriminate the object, right? We are in between the object, we are trying to find out the difference. Or object tracking as well. So in object tracking as well, we are trying to bifurcate between the object and try to understand which object is this, and we are trying to track it, right? Even for the segmentation purpose, when we are doing the segmentation, you might have seen the previous slides. So if this is a picture where the car is available, right? Here is the car available, here is the human available. So what segmentation technique, and maybe here is the building available, some trees available over here, right? So this tree is available. So what this discriminative technique is doing, this discriminative technique is trying to segment the things in such a way that it will be able to differentiate these cars with one color, and then it will be able to differentiate the human with the another color. And if there is another building present or trees are present or any other object is present, it will try to discriminate it using filling the different colors this way. Okay, so this is called as segmentation. Again, there are different techniques of segmentation: panoptic segmentation, semantic segmentation, that we will come to know when we go and deep dive into that topics. But try to understand, when I am talking about the discriminative AI, that means I am trying to discriminate something. I am trying to find out something. Maybe I am trying to find out the object, how it is different from some other object, or maybe I am trying to classify the object, right? So I am not generating anything, right? If you could understand the idea, so what I am trying to talk about, right? I am not creating anything out of this. Even if you do any NLP task, let's understand, if you are trying to analyze any NLP task, in NLP, what we are doing, maybe we are trying to deal with the text data. And this text data, very popular use case, or maybe some other use case, maybe classify based on the text, whether this email is spam or not spam, right? Not spam. Or what you can do is, you try to classify any NLP algorithm, you trying to take a data on basis of this text, or this text could be some sort of reviews, right? Might it be, let's say, we are talking about the sentiment analysis of the movie. So maybe these are the movie reviews. On the basis of that, we are trying to do a sentiment analysis. Again, in sentiment analysis, right, what we are doing, we are trying to bifurcate whether there is a positive sentiment or negative sentiment. Are we generating anything? No, right? But only in certain cases, obviously, we are trying to guess a word, right? What is the next word in the series, maybe? Or we are trying to summarize something at that time, right? But we are not creating anything new, right, out of here. So that is the basic difference in discriminative AI. I'm just trying to classify. Either I'm trying to classify, or either I am trying to track the things, or I am trying to segment the things. But wherein the generative AI comes into the picture, I am trying to create something, right? If I provide a data, let it be a text data or image data, or let it be any video I am providing, right? At that time, this generative AI models, they are trying to generate, let's say, images, right? They're trying to generate images. They're trying to generate a music. If I give a music, it will give me a new music out of that, or it is trying to give me a new video out of an old video. or we can understand that I am trying to give it a black and white image, and it will be able to create a color image for me. Or for that purpose, to understand if I am giving any poster, right, artistic picture, any poster for it, any art or painting, it will be able to generate a real-time picture out of it, right? So this generative AI is trying to generate something, right? Like let it be image, let it be music, let it be video, or let it be any kind of artifact or object. It is trying to create something. That is the biggest basic difference between the deep learning techniques. Understood, guys? What is discriminative AI and what is generative AI? Generative AI is trying to generate something. Whenever you will see an output of any model, right? How you can understand when there is output of any model as a text or as a video, this is the output it is trying to give you, or any image, or let's say for that purpose in temporal music, right? Music, that means a voice. So if it is giving you this kind of things, or maybe a new text, when you provide old text, on the basis of that, it's try to give you something new, a new text. So that is called as generative AI. Hope this and everyone now understand what is the difference between discriminative AI and generative AI. Guys, quickly ping me so we can go ahead, right? So this is the basic difference. I hope everyone is able to understand now, and you are able to understand that what kind of models are used in discriminative and generative AI. So let's try to understand deep dive further what it is. So try to understand what is happening in the discriminative techniques and what is happening in the generative techniques. If you look at the diagram for the discriminative, we are using, let's say, again, how we'll try to bifurcate, even if you are using any text or music data. Here I have taken an example of the music. So if it is a discriminative model, right, of the deep learning model, discriminative model, and I'm trying to give it a music, right? So if I'm trying to tell input is a music, I'm also trying to tell it a type of a music, let's say rock and classical, right? So because it is a supervised learning, so I am giving it also the classes, what kind of classes are available in this music. At that time, this discriminative model will be able to classify the music, right, as a rock music, or the classical music, or the romantic music, or some other category. I don't have much knowledge about the music categories, but at least I understand that whenever I am giving a music along with the labels, I am giving labels, right? So this discriminative model is able to understand, get trained on this data, provided data, and it will be able to classify the things, correct? So similarly, if I give a music, right, to a generative AI, Gen AI model, so it will try to understand the music, but I am not telling any labels over here, right? I'm not telling any categories or any labels to it. So it is taking the data, try to understand the data or distribution of the data, and then on the basis of that, it is able to generate a new music. So this could be a good example how we can analyze what is discriminative technique and what is generative technique, right? So I already told you, right? Whenever the input is unstructured data, right? And then generative model is trained and it is giving you a new content out of it. So usually what we do is when we are trying to do a generative AI, we giving mostly the unstructured data, because again, try to come back to our basics. 80% of the data is unstructured. That's why there is a need of this kind of models. When the output is like say number, classes, probability, or the categories, what it will be? It will be discriminative AI. Right? And when the output is in form of the text, videos, images, it will be generative AI. Okay. I hope this is clear for everyone now. Let's move to the next thing. And then what we do is, what is the basic difference, right? What happens? So when we try to train any machine learning model, right? Or any for that purpose, any deep learning model, what we do is this machine learning model and the deep learning model, they try to find out the pattern between the input and the output, right? This is what usually happens if I am giving any kind of, let's say, this structured data and giving you the output, it trying to find out, it is going back again, trying to find out the relationship maybe doing some kind of calculation and try to understand how these variables are affecting the prediction or target column. For that purpose, this target column, and then try to identify on the basis of that it is doing prediction, right? In deep learning, we are giving similar the images, trying to understand the images, and it is giving us the classification or detection. But in terms of the, let's say in terms of the generative AI, it is doing the different task. It is not trying to identify the pattern. It is trying to find out the distribution of the data, guys. That is the basic difference. It is trying to find out the distribution of the data. And here we are trying to find out the pattern of the data. That is the only difference. This way you can try to make a differentiation between the training of the generative AI and the discriminative AI. Let's try to move forward and try to understand the things. So what happening in generative AI, like how the models are getting trained. Okay. So let's say what I told you that generative AI model are based on the LLM models, large language model. What do you mean by large language model? I also told you in the background they are using even a GAN kind of model or encoder decoder model called as transformer, right? Encoder and decoder model, or could be called as transformers. So let's imagine that my job is to understand that even if I give any kind of question to a person, let's say to my model, right, related to a cat, so it should be able to tell me correct answers, whatever question I am going to ask. For that purpose, what happens is this base model is trained, let's say on huge data set. What do you mean by huge data set? Take an example of the cat. Whatever books are available or whatever information is available regarding the cats, right? Let it be on the online websites, Wikipedia, books, and everything. All these resources are dumped to this model, right? That means this is a huge data which has been dumped to a model, and this model is trying to, in fact, try to learn from this entire data set. Then whenever any person goes to this and try to ask a query, right, about whenever I ask any kind of query to this model, obviously, whatever question I will be able to ask about the cats, it will be able to return me the answer based on the learning it has done. Whatever the content is present in this book or website or Wikipedia, whatever I have fed it to it, it will be able to understand, and then it will be able to give me the answers. So that is how usually the training is done in the generative. We'll try to go back and we'll try to understand also how the chat GPT is trained. What are the 3 stages for the chat GPT, how it is trained, but try to understand a general overview that how the training is happening. Why we are calling them as a large language model? Because they are trained on a huge data set, which is not possible in terms of the machine learning and deep learning. Even the deep learning, there are huge image data set, but you will not able to imagine the way they are exposed to the data, right? So they're taking like months, and they're having around, if you remember, they're having this kind of models are having around 150 billion parameters. When we are trying to create this kind of models in ANN or CNN, how many models maximum we had? Around 1,000 or something, right? At 1,500 or around that. And imagine if we are trying to train on 150 billion parameters. So what will be the speed or what kind of computation will be required for that reason, right? So the basic idea is you try to expose the entire information which is available in terms of the any resources, digital resources or the books or any feedback, and it will be able to understand the topic. If you ask this model apart from cat, it will fail. Okay. Try to remember this thing, because we have fed this model only about the cat books or cat related information, but with a huge information, right? Very huge information, but only related to that stream. If you ask about anything about the cat, it will be able to give you a response. But if you ask about anything else, it will not be able to give you a response. For that purpose, it will act very weirdly, or it may be failing it at that time. So usually what happens is, what are the tasks when we talk about the imager or test? What are the popular tasks which are created by this generative AI model is, let's say text translation. That means I'm trying to translate from one language, Spanish to English, or from Japanese to German. That kind of translation also taken care. Then summarization, text summarization. If I am giving it 1,000 lines, it will be able to provide me a summary within, let's say, 50 lines. Text summarization, text translation, then text to speech, speech to text, back again, text to images, right? Even if you provide a video, it will be able to give a caption in terms of text, that what this video is all about. Okay, that even if you give an image, it will be able to generate a different image on the basis of that. Or you give any reference image, where that image is, let's say, blur image, any blur image, it will be able to generate a very high quality HD quality image for you guys. Okay, that kind of task you will try to perform in terms of the text or languages. We'll also go ahead and try to understand what other tasks are performed by the model. Even before we try to understand these things, there's a very popular concept which is called as prompt engineering, right? What do you mean by prompt engineering? Now we'll try to understand what is prompt for that reason also. So when we are we are also, now we understood that what is Gen AI, generative AI, and now what is LLM. LLM means in base they have these models, those are export to very huge data, right? And the basis of that learning, they are able to return me any answers. Now, but in order to get the popular to get a specific response from this generative AI model, we need to provide the prompts, right? So what do we mean by prompts is, if I write a query to any large language model, so please, let's say this is a chat GPT, and I'm writing to chat GPT that please provide me, okay, please provide me the PPT where in such a way that even for 5-year-old children, I will be able to explain the statistics. So it will be able to give me the details in detail, all the information or PPT where we will be able to explain. So what I am trying to do is, I am trying to write a query that please provide me the PPT in such a way that for the statistics, in such a way that even a 5-year-old children will be able to understand. So when I am trying to provide this request at that time, it will try to understand some keywords, right? So what is the keyword here? Most important keyword, 5-year children, and then the statistics, right? So it will try to understand the context, right? Like we are doing in the NLP, where these bots are trained on the natural languages. It's trying to understand the context. It's trying to understand the different, let's say, what is the request that your user is doing on the basis of the keywords, right? So if you give a correct keyword, it will be able to give you a perfect solution, or let's say perfect prediction accordingly, right? So that is the key term here. And the kind of query you are trying to do here, it is called as nothing but it is called as prompt. So prompt could be a text or could be image, right? So whatever request or query I am trying to give it to my large language model, so that test, or let's say that text, that kind of text, that kind of query, or that kind of image, or let's say for that purpose, any video you are providing, and on the basis of that video, you are saying, okay, this is a 1-hour video. First, please provide me out of this video very highlights in 10 minutes. Let's say there's a cricket match, T20 match, which is going on, which let's say it is between India and Pakistan. Obviously, it is a very exciting match. And what if at that time I am doing my job, right? So it is during my working hours. So what we usually do, we try to come back and try to use the highlights, right? So you provide an entire 3-hour feed to this large language model, and it will be able to give you highlights out of it, right? So that kind of things where we are providing these videos or images or text, that will be called as prompts. So that is prompt, guys. And why nowadays the prompt engineering, we'll try to also look at some example and we'll try to understand what is prompt. But nowadays the prompt engineer job has become very popular, right? Why it is very popular? Because whenever we are trying to create any large language model, LLM model, right? So at that time, LLM model will be able to only fetch the information or fetch the result basis of this prompt only. This is the only way, because we are not feeding any data, direct data, like our machine learning or deep learning model, right? Or machine learning or deep learning model. What we are doing over here, we are trying to create a human interaction, right? Human interaction over here with the model in terms of the query, right? In terms of the query, or that query could be text, image, or video, and we are writing something, right, in the human language. So this is a human interaction that we are trying to perform with our large language model. On the basis of this this interaction, it is able to give us a text, right, or give us a desired result. So for that reason, and how this how the efficiency of this model will be analyzed based on the prediction or based on the result it is providing, right? And result in fact depend on the prompts, because the way you are able to correctly write what you want to achieve, what is your objective, at that time only you will be able to, whenever you are using many specific keywords or terms, on the basis of that only it will be able to analyze your sentiments or your request, and it will be able to fetch you the result. So for that reason this prompt is very important. And whenever we are trying to create this large language model, at that time there will be a separate block where it is saying that I will try to show you how the chat GPT is trained in 3 stages. At that time you will be able to understand that what is the importance of this prompt, right? So there will be one stage where you will be have to train your model especially on the prompts. So there is some stage called as prompt training, right? Prompt training, and this there is a separate name for this training. That when I will come back to this stage, I will try to tell you, okay, what is the name of this training and why it is happening. So for that reason, we are using the prompts, and there is a second stage or third stage at where we are using our model, which is a base model, large language model, to again retrained, because what, just like the deep learning, we don't want our model to be created on the basis of the data. And this again, you are providing information and then you are getting a result. There is no human interaction. But in terms of this large language model, the human interaction is available, right? Human interaction is there. Humans are trying to talk with the models and try to achieve the results. So that is the basic difference between the deep learning model and this model. That's why we need to take care of these things very specially. So that is called as something called as supervised fine tuning. Okay. So I will try to understand, we will try to understand what is supervised fine tuning very quickly. This is called as supervised fine tuning. Supervised fine tuning. This is the second stage of the training of the LLM models or Gen AI models, where we have to provide them with the prompts, different prompts. And on the basis of this prompt, we have to check whether this model is able to give us a desired result or not. Okay. At least now you guys are aware what is prompt, right? We will be able to understand when I am talking about the prompt, that means I am talking about the text or query through which I am trying to get the results from the large language model. Okay, try to understand in this way. This is a product review sentiment classifier. Let's say product sentiments. It is trying to give me. When I say review, like this is example. This is the task we are trying to provide. And when I am saying the reviews, I love this product. So whenever I am saying I love this product, it should be able to give me positive, right? That this is a positive feedback. When I am saying it is a waste of money, it should be able to give me negative. It is a negative feedback. So basically, I am recommend not to buy this product. At that time, what should it do? It should be able to guess, right, whether this is a negative or positive feedback, and accordingly it should be able to provide me the result, right? So whenever I am trying to interact this kind of things, right, this kind of instruction set are there. These are nothing but the prompts, right? I am giving prompts, and on the basis of the prompt is trying to understand and give us a result, right? I hope now prompt is clear, guys. And why prompt is important? That because of the prompts only it is able to give us the desired results. Again, I have collated some of the categories for the prompt and what it's trying to do from this prompt, right? Whenever the example of the prompt engineering could be text summarization, information extraction, question answering, right? Text classification or code generation. Even for the code generation, right? Whenever we are asking our chat GPT to write me a code to design the website, right? Design me website with this kind of key features. Key feature, right? I'm giving a key feature. Please design me a website, provide me the code for that reason, right? Let it be HTML code, or let it be a very Web3 code, or any Python Flask application or Django application for that reason, right? So at that time, what is happening? Whatever information you are saying, if in this case, let's say you are saying a chat GPT that only give me code for website, right? Give me code for designing the website. So it will be able to give you only specific code, general code. It will not ask for what are your special requirement, what kind of text you want to display, or what kind of picture you want to display, what input you are trying to achieve in this website, or are you going to perform any task, right? So if I tell my chat GPT clearly, right? So please provide me the code. Okay. Please provide me code in order to achieve task 1, task 2, and task 3, along with the high level of UX, right? High level of UX, and it should be giving this kind of output. So at that time, we'll try to go back to this prompt and we'll try to find out these keywords, and the basis of that only it will be able to give you a code. Otherwise, it will fail simply, right? It will be giving you any code, let's say random code, which will be of no use, and then the entire purpose will be defeated for this large language model, right? So that is why the prompts are very important. And why prompts are important? Because you don't know, human are interacting, so you have to think from the human point of view, that how the way with which sentiment or analysis or with content or which context this person is trying to understand. My entire large language model should be able to understand all these kind of scenarios, and these scenarios will be coming from the prompt training only. So that is the reason it is gaining the advantage in the market. That's why the prompt engineering job is very important. Okay, I hope now this makes clear that why prompt engineering important, why it is a crucial part of the training, and that is why the reason that prompt engineering is there, right? Let it be creation of any code or classification, any text classification, right? You can give an entire full article, it will be able to give you a summary of the article. Or you, let's say in this case, I have written that to text GPT, MS Dhoni is one of the captain in the India who won all the ICC events except for Test Championship. So it will be able to understand even from the unstructured data, right? I'm going to give this kind of test, and it will be able to give us structured data in this way, like, so Indian captain, it is related to the cricket. This kind of information, my zodiac sign is Libra, and then India surpasses the UK and become the number 5th on the GDP. So this combined text I have given, it was able to give me the bifurcation structured sequence out of it, right? So it created different block for GDP related information, different block for zodiac sign, and different block for the sports sentences which I have written, right? So that kind of task will be called as information extraction. Sorry, information extraction from the unstructured data. So, or very popular use nowadays, which has been done by the people, are question answering, right? Question answering. Any student is asking how to solve the hypothesis test. This is the example of the hypothesis. Please try to give me a step-by-step information how I will achieve to this solution, right? Each and every step with all the calculations. So this kind of question, right? When I am asking, at that time only I will be able to give you entire step-by-step calculation. If you tell me, only give me the solution for this hypothesis test, it will directly jump to a last conclusion value and it will fetch you the value, correct? Or even for the matter of the news classification, you dump an entire news article, it will be able to segregate them on the basis of the classification and trying to understand the context and everything. So that is why the prompt is important, guys. So now I think everyone understood what is Gen AI. Is nothing but it's trying to create something, the algorithm which are trying to create something, right? And these are the news, right? Mid Journey or this kind of application. AI news anchor is again into the picture nowadays, right? So Odisha is the first state which was able to create their own regional language news anchor, right? After that, there is one more created by the Karnataka state, and some other state are trying to mimic them, right? This is called as the humanoid bots or avatars, right? So there you are giving any reference image to these LLM models, and basis of that it is trying to create this kind of picture, right? And this picture will be avatar of any person who will be working as a news anchor, and in fact it will try to give you the news related to different information in different sectors and related to different categories, right? So whenever you are trying to play a game also, right, you try to upload your picture, it will create a picture out of that. What is that? That is also generative AI, because you are giving your picture and it is creating this kind of clear picture out of that, right? Or maybe it is trying to create a fake news, right? So we have seen that there are very fake news created, or maybe there are incidents reported that where there is a morphing of the voice is done. You are getting a call as someone who you not expected. There was a recent incident where the person got a call from his colleague, and she's asking him to transfer GPay some amount, and then he transferred, and again that person was asking to transfer some more money. At that time he called a person and she denied that I did not call you, right? So that kind of things are happening. That's how the AI responsibility or ethics are also coming into the picture. Try to understand again going forward. These are some important points or highlights which I wanted to bring upon, right? Even the students are nowadays saying that we don't need any personal tutor, right? We have a chat GPT who is able to explain us line by line and by step everything. Or let's say this kind of image, distorted image or image with the noise is given, noise, right? This is a noisy image, very distorted image. You try to generate a good image out of it, right? This kind of image. So this is also done by the AI based, generative AI based the models, which is also a popular application Mid Journey, which is able to generate a picture out of the distorted image, right? Or even they are trying to provide the distorted picture or black and white picture where it will be able to give a colored picture with the some even extra voice quality, right? The voice quality is also improved. So that kind of experiments are also done with this. Now everyone understand that what is the procedure and how it works, right? Or let's take this example in case when I am trying to give, right? How it is trying to generate, even this was a use case. I will not go into detail, right? We have discussed already. Usually what happens is whenever we are trying to write any sentence, let's try to understand this. So whenever we are trying to give any, by the way, guys, GPT means generative pre-trained transformer, right? So everyone is aware of what is GPT. So I have purposefully, even whenever we talk about GPT, we should be knowing that what does this GPT means, right? It is a generative pre-trained transformers, right? So that is the GPT models. I told you in the background, they are using transformers, right? Transformers means of encoders and decoders. I will try to understand what is encoder decoder and also the GAN models. So it is a generative pre-trained model. That is the base model they are using. On the basis of it, this is trying to go it to the second stage of learning, which is called supervised fine tuning. Then it will go to a third stage, which is called as reinforcement learning with human feedback. So these are the three stages through which all these models goes and then they try to create this kind of final model. That we'll try to understand. Let's say if you're trying to train your model on the sentence creation, right? So at that time, if you provide any sentences, right, it will be considered as token. What happens usually in the sentences, right? Whenever I am saying I am going for shopping, right? I'm going for shopping. Just ignore the spellings and all. Let's say I'm going for shopping, right? So at that time, what happens is how the models are trying to, how the model trying to bifurcate them is first they do a tokenization, right? So tokenization means they try to tokenize, means bifurcate this entire sentence into the words. If it is a paragraph, first sentences, then out of that words, and that words will be taken into form of a matrix, right? Let's clarify everything. These words will be taken into form of matrix, right? In whatever words, let's say I shop and going, and then they will try to assign certain weightages to this model, these words according to the frequency. So what is the frequency? At what frequency? Let's say this appear 2 times, this appear 3 times, this appear 4 times. Accordingly, they are giving the weightages, right? And on the basis of that weightages, now they're trying to understand what is the keyword and are taking the context of that keyword into the next layer. They are trying to understand. If I am saying I am going for shopping, right? I am going for shopping. At that time, it will do a tokenization. This is a chunk of what I told you, right? Tokenizers. This is how the NLP, entire NLP algorithms also work. They try to tokenize them. Out of that, they remove the stop words. Stop words means the words, if I am remove those words, still I will be able to make out the understanding of the sentences, right? So if I am saying I am going to study, if I tell you only I study, then only you will be able to understand that I am studying. I am going to study. I am going. These words are called as stop words because even I remove these words from the sentences, still I will be able to understand the context or the meaning of this word. So first thing, what happens is whenever the sentence comes in, they try to tokenize them as the words. And then out of these words, they remove the stop words. And then whatever words are remaining, they try to create a word to vector, right? Word to vector, sorry. word to vector, which is the matrix, depending on the frequency, then adding the weightages, then they are trying to classify the things and they try to understand the context. This is what the new normal languages works upon. Even when I am writing the sentence in the words like running or I am going to run, so it is trying to bring them to their normal version, right? When I'm using adjectives, something like that, to try to bring them into the normal format. So that is called as lemmatization, right? Lemmatization, and some other concept is there, right? So that is also applied, and then on the basis of that, it will be able to understand the things, and then it will be able to give a weightage and everything, right? This is how happens. And then, but what was our scenario here is that if I write some sentence, I am going for shopping. I am going for shopping, right? So it will be able to understand this context through these keywords, and the basis of that, it can generate different inputs. Maybe if I'm going shopping, I need a car, or I'm going for shopping, I need a money, or I'm going for shopping, which one is the best, right? Mall, super mall available where I can do, right? This kind of sentences you try to understand this way, and then it will be able to generate, right? The term encoder means who encodes all the translation of words into symbol and known as encoder and decoder opposite to that. Yes, guys, that's what, but we'll try to understand these things. Okay. So this is the example which I've given, right? If I'm saying she went to a store, then what will be the new word? Maybe on the basis of the vectors, on the basis of the tokens, let's say this GPT is trained on the 32,000 tokens, right? Tokens, now you understand what is token. Token is chunk of the words, right? And on the basis of that, you try to create these tokens or vector of the tokens, and you try to give a probability, whatever the highest probability word that will be coming up, and it will be used, right? If she's saying that I went to store, then what will be the next word? Maybe shopped, right? Or maybe bought. And this is how it is happening, is basis of the tokens it is trained upon, right? Whenever the people talk about LLM, they talk about the prompts, right? These are the popular keywords now. Prompt, LLM, right? And Gen AI. Now you guys understand these terms. When they talk about the tokens means nothing but the chunk of words which are given as a training data set to it, right? And that on the basis of these tokens, right? Whenever people say that this is a new model which has been introduced and it is trained on these many tokens, right? This is what they say whenever they talk about the generative AI or large language models. So the token is nothing but a words, and chat GPT is trained, GPT-4 is trained on the 32,000 words. And why it has to be trained on this word? Because it will be able to guess the next word if I provide a half sentence, right? And this kind of use cases, text summarization, information extraction, or generating a new article out of the lines, keywords which I have given. It will be able to write an article for you guys, right? So this kind of time, I will need this kind of tokens, right? So imagine it is trained on 32,000 tokens. On the basis of that, on its own data set and corpus, it will be able to generate the things. So it can generate sometimes weird also. She went to store and clocked in or something danced. So that is also possible. That is called as hallucination. I'll not go into detail. So, okay, try and understand that what are the popular products available, right? Chat GPT is not the only large language model which is available, guys. Chat GPT just one version. Apart from that, there is something called as Stable Diffusion, DAL-E. Okay, for Google, it is Bard, and for Microsoft, it is Bing, right? Sorry, Microsoft Binge. And for Hugging Face also, there is a similar, and even UAE has come up with a new model, which is called as some model called as Eagle. It is a shortened version of the chat GPT, not Eagle, sorry, Falcon. Sorry, guys. It is Falcon. This Falcon model given by the UAE. Okay. And where chat GPT is trained on the 150 billion parameter, right? And where this model is trained only on 10 billion parameter, but it's still able to compete with the chat GPT. So this kind of research is going on, and these are the popular model. We'll try to understand. DALL-E is able to create the images. Bard is also able to work similar to chat GPT, where it is trying to create the things. Binge is also able to work as a code interpreter, code analyzer, and also able to search the images and reference images, right? This is the list of the different products available, waiting for the launch of Google Gemini, correct? Chat GPT even 4, DALL-E this is the Delhi, guys, architecture of the Delhi. I will not go into detail, but I will try to tell you a few things. What is the architecture and what how it is trained, right? Delhi is Delhi 2 is a OpenAI. It's provided by OpenAI, right? It can generate the image from the text, right? It can generate the image from the text. Also, it can give you a new feature out of the old image, and then also it will be able to give you a, and it works on some kind of concept which I will be talking about shortly, right? So again, why I'm trying to take this example and try to give you idea that how these models are trained and what are their usability, right? This model is specially used for generation of the text, generation of the images right from the text. And in the background, what happening is, since we already learned the convolution neural network and the artificial neural network, there will be two blocks, right? I told you, right? Encoder and decoder, and in between there will be layers, right? And what they are trying to do is, they're having the special concept called as contraceptive language image pre-training. This clip model, this is working separately along with our parallel model, where it is able to understand from the language. So what is the requirement, that it is trying to understand that requirement in terms of the prompt and tokens. And on the basis of that, it is able to provide it to the encoder and decoder. And this encoder and decoder, in fact, able to create the image. So try understand only these things. We'll try to go back and try to understand even what is encoder, decoder, and what is GAN, everything. But I will have to rush through. But I wanted to show you that this is the architecture which lies in the DALI 2, right? That's kind of the application. Even there is one more application which is called as stable diffusion, right? It is also used for text to image, and also it is using the latent space and the Markov chain. What is the latent space and everything, that we'll try to understand in coming pictures. But it is try to give you pictures. You provide this reference image, it will try to create this kind of images. Let's say this is the image. If you are saying that text, you have given a text, right? Train during monsoon. So this kind of images you will try to create. Train image, monsoon. The monsoon is going on, the train is going at that time, right? So also, if you guys have seen, they have this large language models are making very huge differences in terms of the gaming also, right? So try understand in gaming how they are trying to make the changes. If trying to revolutionize in that gaming industry, that's for that reason I have put in two graphs, right? One graph is showing how year by year the number of research paper which are presented for the ML and AI. If you could remember, it started presenting various, let's say, state-of-the-art model from 94, but the major research paper were developed using the 2012. Okay, so if you try to look at these timelines, the way you are seeing that it is increasing day by day. Every day there are lot of research paper, and you can say it's between the thousands now. Thousands of research paper are nowadays published. So that is one of the reasons why there is a revolution going on in the gaming, not only gaming industry, or entire image and video sector, entire image, video, and the way we are trying to intercept the thing. Just for the reference, I am giving you example that how the entire industry is getting revolutionized, sorry, because of this AI. Why? There are major two assumptions. The way the research paper or the models are published, and way it is impacting the entire games or entire arena of the games in terms of the let it be arts, TV shows, music, and all. So in coming within 1 minute, I will be able to tell the how it is able to help, right? So if you remember, there is a I don't know whether all of you are aware of this game. This is a game called as Red Redemption. Okay, this Red Redemption, try to understand what are the consequences of this creating these games when we are not using Gen AI, and after using Gen AI, what is the huge transformation that is making. That we'll try to understand this very quickly within 1 minute. When this entire model or game is created, right, and it costed around $500 million, right, just to create this virtual reality, the kind of levels of the games. And imagine it took 8 years to build this game. 8 years, 1000 non-playable characters it has created, and 30 square miles of area it is trying to cover in the game, right? 100 missions, it has given mission, right? Level 1, level 2, that kind of missions. 100 mission it is giving with the 6 chapters. And this is really a big game which was invented, right? So this, it took 8 years and $500 million to create it for this kind of thing. Even 100 musicians were hired to create a music for this game, right? So for that purpose, Microsoft also came up with one more game, which is also huge, not only huge, it is enormous, like very, very huge as compared to the Red 2, this Red Redemption 2, right? Where it was able to simulate using the fight simulator, which is able to create, like it is giving a personalized experience as if you are trying to fly over entire Earth, right? It is trying to give you that kind of virtualization, and how they are able to achieve is making a partnership with the Black Shark AI, and they are creating the 3D images out of the 2D images. Whenever we are trying to take pictures, right? So it is mostly in the 2D images. They try to created that using generative AI 3D images, and then now they are able to create this entire things or the entire game in the virtual reality, right? Where you will be able to understand that actually you are going and visiting to these places and you are flying the aeroplane, right? So that kind of huge transformation without spending this kind of money, right? 8 years to build and $500 million and 100 musicians, but it was able to mimic the generative AI and was able to create this kind of game within less amount of efforts, right? So that is how the depth you can try to understand. We already discussed what are the major tasks when we are talking about sequence to sequence encoder decoder, right? So we also spoke about that in background when we're talking about the large language model. They are using encoder decoder. So let's try to understand what is encoder decoder within quick 5 minutes. So we have a limited time. We have to also understand how the chat GPT works and what are the training procedure. I don't know whether we will be able to cover, but I will at least try to show you how the model look like. Okay. So sequences, these are sequence to sequence model, also called as part of the transformer encoder decoder. What they are doing: image captioning, sentiment analysis, and translation, right? Majorly. So try to understand very simply. If you want to understand what is encoder decoder, remember any game, Pictionary game or dumb charade, right? For that reason, clear one, we are telling him one name of the movie, right? We are telling him name of the movie or any text. For that reason, here I am giving rabbit. So what he has to do, he cannot go and tell it to the person. He has to either draw this one or he has to make a acting, right? He has to make the acting. For that, our large language model, we try to understand that he had drawn a picture, right? Pictionary. This game is called as Pictionary. Player one is trying to create one picture. He know about the context of the picture. So looking at the picture, person two or the other group has to tell that what is this picture belongs to, right? So this is a simple Pictionary game, and whatever if he predicts it correctly, he will win, right? Will get the points accordingly. So similar thing is the encoder decoder model. These are the base RNN model. Base is for RNN models, right? Neural networks are trained. But what happening is, encoder, what they do is, whenever we try, let's say in this case, we are trying to translate the Spanish language. So I told you, whenever I am giving the language, it will try to chop it. Whenever I am giving paragraphs, it will paragraphs to sentences and sentences to words. That's what it will do. And it is trying to take sentence word by word, and it try to decode it in some certain way, which is called as hidden space, hidden state. In hidden state, it is trying to assign some number to it. Let's say 1, 3, 5, and this is what it does. And then this hidden state is passed to the decoder. This decoder, now it will be taking the hidden state and it will try to decode the things. Using this hidden state, it has to analyze that what this number means, whether this number means esto, say B or M or some that kind of words, and it has to translate back to the English, right? It has to translate the English. This is what the encoder decoder does, right? And what they do is, they have a recurrent neural network stacked over each other, and they one by one these tokens are taken into the neural network. The neural network at layer 2 or layer 3 will be having this back connection with the previous layer, but it will be able to understand the context, right? It will be able to understand the context and try to remember when we are moving to the next layer. At that time also, this will try to remember. That is called as LSTM. Okay, long short term memory. So they are having references back to each other, where they will be able to understand the meaning of the previous sentences. Will try to store somewhere between, and then it will try to decode and encode them. So that is shortly what encoding decoding means. So there is a concept called as hidden state. Encoder try to encode the words or embeddings or prompts, and then it will be providing into hidden state. Hidden state will be the input for the out decoder, and from decoder, from that language to the another language. This is how they will try to convert them. So again, you will ask that what is the architecture, what is the code behind it? That I will try to show you. Right? Just a moment. that I will try to show you guys encoder decoder model when I make a code walkthrough. At that time, try to understand whenever we're talking about the generative AI model, the base model we understood transformer, which is in fact using as encoder decoder. So this is the architecture of the encoder decoder. And try to understand the next word is GAN model, right? Generative AI model. Yeah, guys, feedback link is given. Amar, he will be providing again. So there is another model called as GAN, right? GAN means generative adversarial model. This generative adversarial model has two components. One is generator, one is discriminator. What usually the idea is over here is, I will try to explain in coming steps also. There is one generator and one discriminator. The images passes through and then they dare to bifurcate, right? This image is provided to generator. Generator will create a fake image out of that, and this discriminator will be able to pass or fail the image. So this kind of epochs will be going on, and at a certain level, this generator will be able to create a fake image in such a way that it will be very similar to the real image. Okay, so that kind of clarity it will try to bring, and then at that time, this discriminator will fail to analyze whether this is a real image or fake image, and that fake image will be passed. This is the basic idea what the GAN model does. Okay, try to understand. I told you that what are the application of GAN model is to generate a data from the available data, generate pictures, right? Generate music, or generate from text to image, or image to image, or from low resolution image to high resolution image, or predict the next frame in the video also. What could be the next frame in the video, or what could be the next speech if you provide a corpus of the speech. So what could be the next speech? That kind of application is done by the GAN model, and this is the architecture for the GAN model. Okay, like I told you, this again, this is called a generator where we are passing a data. Okay, guys, let us go through it quickly because it is self-explanatory. We are trying to create an image which is a fake image, and also a training data set is there. On the basis of this training data set, this image is created. They try to cross verify. This discriminator try to cross verify, and if it is not able to verify, it will tell whether it is real or fake. And certain point of time, it will try to achieve very high quality fake image, whether it will not be able to discriminate between real and fake, and that's how it will get passed, right? So that's the basic idea. But in the background only, there are also blocks of the different neural networks are working, right? Neural networks where convolution blocks are working, some recurrent neural networks are working, and then they are trying to create these things. What is maximum limit of LSTM for the input data in any process? Including that we'll try to understand, guys, later on. We have to important topic we have to still discuss in our code walkthrough. This is the procedure how the GAN networks are done, right? There are different GANs available versions, right? DC GAN, conditional GAN, least square GAN, dual ludo GAN, cycle GAN, info GAN, right? And this is one more thing which I have put in here, that to understand that what is the future work and how the generative AI is going to impact the work and all. So we'll now try to discuss these things. And also I spoke about the ethics, right? Ethics very important, that what are the ethics and why we have to follow it, and who will take the responsibility for all this reason. Fake image, okay, that's a good question. I told you that if I give any text, I will be able to generate image, right? So how using text I will be able to generate image? The only thing that I start creating something which is not as per the reality. So that why it is called as fake image. So then once this fake image is created, again it will go back and learn the weights, kernel and matrices. It will again come back, this back propagation, forward propagation, everything will work. And at that time, it will be able to give us a correct image. So that is the entire work what we're trying to achieve here. Because if I provide a text, at that time you should be able to create image. For that kind of task, we have to first create a fake image which is not exactly matching to the target image. Then the way it will try to learn the things, then it will be able to create exact match, right? It will try to understand all the filters, weights, everything by doing this process. So once it is capable of doing this thing, at that time only if I provide a text, it will be able to generate the image. So that is the entire thing why we need to create this kind of images. So guys, these are the top companies along with their valuations, that who are the top companies. OpenAI is obviously a ranker over here. This is the topmost company. Hugging Face, Jasper is there, right? Some other companies are there. You will not be able to see the name of the Google and other companies, right? Microsoft, because this is what I wanted to show you. Rarely people understand that only Google, Microsoft, or let's say Meta is doing the work, but this is not the reality. Look at the valuation, then you will be able to understand what are the top 10 players in the AI. Models, again, I told you that there is a large language model used. Large language model is based on the transformers and the GAN model. But what are the models which are LLM models are available, right? So that model is called as Jurassic 2, Claude, LLM Core, or for that reason, Google's PLM model, right? Meta's LLMA model. For Hugging Face is the Blue model, and for OpenAI it is GPT. Now we'll try to understand what do you mean by GPT, right? So GPT is nothing but a large language model, LLM model, which is created by OpenAI. Likewise, NVIDIA has Nemo, Meta has Llama, Hugging Face has Bloom, Google has this one, Palm, right? And this Claude by Anthropic, and AI21, Jurassic 2. Yeah, Amar will be providing feedback, guys. He is providing in the common chat box feedback link. Okay. All right, guys. So now we'll try to understand that how the training is done for the chat GPT. Then I will be able to show you code. When we do a sentiment analysis, do we need encoder, decoder, or only encoder as BERT in encoder? No, we will take both encoder, decoder at that time also, or we can use a different models for that reason also. Yeah, guys, try to quickly understand that how the training happens or how the chat GPT is trained, right? We have very less time, but I still have to cover lot many things. So that's why I'm trying to rush through the things. Maybe later on I give you 5-10 minutes to ask the questions. Okay. So very favorite. Now you guys understood what is prompt, what is generative AI, right? What is GPT with generative, right? It is a generative pre-trained transformer, right? Generative pre-trained transformer. So how the chat GPT 3.5 or 4 is trained, that we'll try to understand. It get trained in the 3 stages, guys. First, what happens is we provide a structured data. Okay. First, we provide a structured data, and then the model will be developed. And this structured data will be very huge data. Let's say for that purpose, if I'm trying to give a mathematical model, it will try to cover all the entire world information, whatever information they can fetch, books, libraries, digital data, everything. And then there will be a transformer model, right? Transformer model, which is maybe a encoder decoder model, or could be a GAN model. Okay, that is trained, and then it will be able to perform the task, right? What kind of task it will be able to perform? Text summarization, text summary, text generation, text classification, right? Or even image generation, video generation. That's it, right? That kind of task could be performed by performed by this transformer model. Right? I will use a different color. Okay, this transformer. This is the base first level of training, stage 1. Okay, but now our use case is that we don't want this model, right? This way. So we feed something and it will be able to give us the output. But in fact, what we want is when this model is trained, this transformer is trained, right? In the background, we want a human interaction, right? Here, human interaction, and through this interaction, through the prompts, right? Through the prompts, I want the result, right? I want results. So that was the use case when we are not able to solve using the normal deep learning model, right? Normal deep learning model, I will be giving the unstructured data, and then I will be creating a model based on the transformer or GAN or this one, and it will be able to perform different tasks for me. But where is the human interaction? Since we have seen the chat GPT, and in that, let's say in kind of a chat box, I am trying to give a information, on the basis of that I am able to generate the information. So how this will be solved? For that reason, what they did is they went to a second stage. Stage 2. Okay, and stage 2 is called as, sorry for the guys, handwriting, supervised. Stage 2 is called as supervised fine tuning. Okay, supervised fine tuning. Here, what happening is, guys, in supervised fine tuning, SFT, right? It's called as SFT. Can I understand this? First, we trained in stage 1, just like the deep learning models works. We trained our transformer model, which are encoder decoder models, or maybe a GAN model, and which is able to generate image or something like that, or are able to create anything. But what I want is human interaction. So what happens is, once I come back here, so they try to create a supervised fine tuning SFT model. In SFT, what happens? Human 1 and human 2, right? Human 1 and human 2. Literally, human 1 and human 2, they try to make a conversation. Human will ask some question and human 2 will give any answer. Again, human 2 will ask some question. This will again give any answer, right? So this kind of training, this kind of prompts will be generated. Human 1 asking something, human 2 replying to it, human 2 asking question answer session, right? Question answer session will be happening, and then the entire whatever things we are creating, right? The text, right? In form of questions and answers, we are creating text, right? These texts are called as prompts. These are prompts. Okay. So these prompts are generated. Now we are a corpus of prompts. It's called as corpus of prompts, corpus of P. And this is the single example I have given. What will happen is, this will happen on very high, large scale, very large scale of interaction will happen, and they will try to accommodate this kind of interaction in terms of the prompts. And on the basis of these prompts, again, my model will be trained. This large language model will be trained in stage 2. That is called as SFT, supervised fine tuning. Getting now how the prompts are coming into picture. If you want to create any large language model, you need to have a prompt. And how we generating prompt is literally through the human interaction. Human conversation is happening, and all this data is taken into multiple forms, like billions of such token. You remember 35,000 tokens. This is how the chat GPT is trained, right? So they are taking big tokens, large amount of data, which is the actual human interaction data, and then they're training the model over here, right? So that is the stage 2. That is called as stage 2. That is SFT, supervised fine tuning. Okay. And in third stage, what happens is, I will tell you in third stage. Just 1 minute, guys. Give me 1 minute. In third stage, what happens is, now the SFT training is happening. Once this model is trained on this SFT, what they will do is, they will try to do a request, set the request to our model, and the model will be able to give us the answer, right? This is what happening now. So the third stage will be now called as reinforcement learning, human feedback. Okay, reinforcement learning, human feedback. Here, what is happening is, what usually try to understand this reinforcement learning, human feedback is, or human, let's say human feedback, right? Reinforcement learning, human feedback, HF, not HF, human feedback, right? RLHF. This is a very important concept. At the third stage, the chat GPT get trained, right? What happens is, let's say I have a chef, right? This is my chef. Whenever I go to any restaurant, I'm trying to create one chef, right? This is a chef. Okay, if you go to any popular restaurant and you ask chef that, please give me a customized dish. Give me a customized dish. So what will happen is, we are not telling anyone, right? We are not telling anyone, right? This chef, that what to do. We are just telling, give me a customized dish, or give me your favorite dish. Chef choice, right? Chef choice, something like that, right? What he does is, at that time, he just try to create random dishes, right? And whenever people write that dishes, he will try to rate them, right? Rate one, ranking two, ranking three. The similar concept is applied over here in the reinforcement learning human feedback. Whatever the model is there, which is trained on the SFT stage, supervised fine tuning model. So this model, again, we will expose it to the different requests. This requests will be in the form of the prompts. Okay. This will be nothing but the prompts. And if we give any prompt, what will be the result he will be giving us? Result 1, result 2, and result 3. Okay. And whatever result he is giving, if he is able to give me a correct result, he will give a more points, higher points. This way, right? This way, feedback, right? Feedback, let's say feedback and reward, right? Reward and feedbacks. This is what will happen. And whenever this model is trying to give me a wrong feedback, I will punish it. And whenever it is giving me a correct thing, I will try to give it a point. So this way, it will be able to learn from the error and the rewards, trial and error. And this is the third stage where your ChatGPT model will get trained, right? Here, I am exposing it to the different real-time prompts, and the basis of the correct prompt and whatever information is fetched, I am giving it a reward in terms of the points, right? So the correct response will have highest probability, let's say 0.9, and the lowest will get a wrong feedback, will get a very less priority. This way, they again train the model, right? Reinforcement learning. And then this model will be used as an then final LLM model, large language model, which you will be getting in terms of the browser, and that will be called as ChatGPT. Okay, guys, this is the entire architecture, how these ChatGPTs get trained, right? In 3 stages. First stage, normal model we create, right? Transformer or GAN model encoder with a huge amount of data. Now that usually the data is very huge, then that is exposed to SFT, supervised fine tuning, where actual human interaction data is taken as a prompts and trained again, and then they will be exposed to the reinforcement learning human feedback stage. This third stage, again, they will get a reinforcement learning, and then it will be creating the application out of it. I hope, guys, now you are able to understand how the things are happening, how the ChatGPT is trained, what is the working behind it. Just quickly ping me, guys, so I can go back and try to show you just one simple code for encoder decoder. Let me share one encoder decoder model with you guys, which is creating the image. This is simple auto encoder decoder model, guys. And what we are trying to achieve over here is, if I pass this blur image, it should be able to give me a high quality image, right? I'm just trying to tell you the structure. I will not make entire code walkthrough because I know there is only 7 minutes are remaining for us. But try to understand what is the background, what is encoder decoder line, and what is the structure for it, right? So once you understand this, then you know already how to create a large language model. Only the data will be different. SFT stage will be there, and the human interaction, reinforcement learning, human interaction will be there. So in first stage, anyhow, you have to create encoder decoder, right? And then second stage is SFT, supervised fine tuning, and then third stage is reinforcement learning, human feedback. So for that purpose, you have to create encoder decoder, right? And then I'm trying to show you the encoder decoder model here. And what is our aim? If I give a blur image, then that blur image will be encoded to a latent space, and from that latent space, decoder will be decoding and creating the image. And similar structure will be for the discriminator or generator, right? GAN model. So guys, this data set is a Flickr data set, which is available. Try to understand first what we'll do is we try to import the Keras library and the loss function optimizer and everything the way we are doing, and also some libraries just to plot matplotlib, just to plot our accuracy and everything, right? Train size, test size, this is 384 images, inference is 224 images. We are just trying to take a Flickr image, this image data set, which contain the 30K images, right? clicker images, we're trying to split them, right? So if you remember, if you look at the number, 31,000 are there. Out of that, 30K is used for the training and remaining used for the testing purpose. So we're trying to make them split and try to understand what we're doing is we're trying to add a noise also. Noise means there is a noise, right? There are different outliers or different blur images present that we're trying to handle. This is how the noise is. Image, this normal image, this is now converted with the noise, right? This is what our input is for the model. Then what we have to do is we have to create a generator, data generator, the way we also created yesterday, right? The data generator, which is trying to access the path, trying to go loop through the each and every image, then it is trying to resize it, then it is trying to give again back, right? Amount of noise, because what I have to do is I have to take the image, give an image noise, and then return the image. So that kind of task is done. Then we'll try to understand how the encoder decoder is built, right? In encoder, again, we are taking 7 layers. Okay, 7 layers of what? Again, convolution layer only. In convolution layer, first, and how the things will happen is we try to increase the filter layer by layer, right? Whenever you go through these things, and then when we are going to the decoder, we try to decrease these filters layer by layer. That is the only difference between encoder and decoder in the coding. We are using same thing again, the convolution 2D neural network. For that purpose, I have imported a shape, 3 channels, right? Color images. And then I am trying to mention that in layer 1, I will be having 64 filters of 3 by 3 with padding, activation function ReLU. Okay. And then second filter will be, and the activity regularizer, it's you guys understand only. Then layer 2, I will have again 64 filter of 3 by 3, again with the padding and activation function. In layer 3, I will do pooling. Okay. I will do pooling, and then I will apply a dropout layer. Then layer 4, again, I am trying to increase my, right? I am trying to increase my filter. Again, I will take 128 filter by 3 filter, padding, activation function, and regularizer. Same again, I will try to create one more filter for 128 by 128 into 3. Okay. Then max pooling, and then convolution 2D. Again, from 128, I am increasing to 256 filters. So this is how 7 layers are created. This is called as encoder first. What it will do is try to encode this image, blur image, into a latent space. And from there, it will be try to decode the decoder. In decoder also, what we'll do is first we'll do upsampling. Why we're doing upsampling? Just to return the images in better way. Then again, same layers, convolution layer. But what we're trying to do is we are trying to take first highest number of filters, then filters are reduced. Right? First, we are taking convolution layer where 128 filter. Then again 128 filter of 3 by 3 with same activation and padding. Then upsampling, then convolution layer is again reduced to 64. And then this is the final layer where I'm taking 114, okay, filters. And this is passed to my last layer again, right? And this is how the model will look like. You can even visualize this layer by layer, how it is there. And then we'll try to compile with our RMS crop as our optimizer and learning rate we are taking. And since this is a binary cross entropy, because we are trying to bifurcate only in real and fake image or something like that, then we are giving the epochs and how many epochs you are trying to fetch and fit the diagram. And that's it, guys. So this is how encoder decoder, nothing else but same, similar to our convolution neural network, but the way we are stacking the convolution layers and some of the functions are different. And then we'll try to evaluate. So it is at least giving me 50% accuracy. And what will be the result? This way. This is the noise image we gave, and this is the reconstructed image, and this is the original image. See, guys, it is trying to create, this is fake image, right? Because this is not the original image. This is called as fake image, but this is fake is nothing but it is a generated image, predicted image. It's reconstructed image is fake image, right? It has created fake image, but fake means not fake. Out of this blurred data, it is trying to give us an image which is near about same to original image. And they have printed similar example for here, right? See what kind of blur image is there, and then it is trying to create a very beautiful image. So similar thing, whenever we are trying to pass the encoder, decoder, or transformer, similarly from text to video, video to text, or something like that, the same things will be happening. Okay, guys. So that's it from my side. I think we understood what is large language model, what are the encoder, decoder, transformer, what are the implications of the large language model, what is prompt engineering, right? What is prompt engineering, what is generative AI, how it is different from the normal AI. I hope you guys enjoyed this session. So I will try to conclude, but there will be our manager who will be talking to you guys for 5 minutes, and that I will sign off. Okay, from my side, I will stop sharing, and I hope that you guys enjoyed and try to understand, right, how the things are working, what is Gen AI, what is Chat GPT, how it is trained. Everything is now clear for everyone. What is prompt engineering? Okay, all right. From my side, I am done. Amar, you can take it over.
Thank you so much. So for addressing, we have Mr. Irfan sir, EDL manager of ExcelR Solutions with us. So sir, please.
Yeah, thank you, Amar. I hope I'm audible.
Yes, you are audible.
Yes, sir, you're loud and clear.
Okay, yeah. Thank you for the response. So hi, Irfan this side from EDL MOU division. So good evening, all faculty members who attended this fantastic FDP program. Going forward, I just wanted to take a moment to thank to our trainer, Mr. Vikas Narune. That was fantastic. 15 days, Vikas, and that was the first program we have conducted for 15 days. First FDP program we have conducted for 15 days with CBIT Hyderabad. So after that, I would like to show my gratitude towards the CBIT Hyderabad, especially Ramkrishna sir, who initiated this FDP program and took very much effort to make it happen. So Ramkrishna sir, then principal sir of CBIT Hyderabad, and the entire advisory committee, the ExcelR management, Mr. Ram Tawa, the CEO of ExcelR, Mr. Srinivas Reddy, the director of products, and Mr. Sham Narayan, who is the director of HR and operations. So and lastly, of course the technical support team, Amar and Leela, that was excellent technical support throughout 15 days. And last but not least, you guys, you participants, that I would like to express my heartfelt gratitude for your participation in the faculty development program on deep learning for NLP and computer vision, which was held from 10th of July 2023 to 28th of, that is today. That was a long program, July 2023. So the program held from 3 p.m. to 5 p.m. for the duration of 15 days, daily 2 hours per day. And your enthusiasm and active participation in the program made it a great success. Literally, guys, it was a great success. So your dedication and interest in learning the latest techniques in deep learning were truly inspiring. So your contribution to the active participation were truly and greatly appreciated. So and this will go a long way in helping you to apply new knowledge in your professional practice. I hope that you found the program valuable, and that you will continue to apply your newly acquired skills in your professional career and in your academics and research. Once again, thank you for being a part of this program and for your commitment to professional development. Thank you all of you. Yeah, over to you, Amar.
Yes, thank you so much, sir. So team, coming toward the certifications, so I would like to inform you that those who attended 60 and more than 60% of the sessions, they will receive their certificate via registered email ID within 7 working days. I hope it's clear. Please confirm in the chat box. Okay, I'm sharing the attendance link once again. Okay, good. After 7-8 days, if you feel that I attended all the sessions and I marked the attendance as well, but not received the certificate, In such situation, drop an email to edl@excelr.com. Our team will check your attendance and update you. Okay. I'm sharing that email ID with you guys. For now, if you have any query or question, please drop in the chat box. I will take it up.
All right, guys, from my side again, once again, thank you very much. You guys really did an amazing job. The way you guys responded, the way guys you trying to learn the things, the way you guys were asking the question, it is really interesting and really amazing. Remember, try to analyze whenever we try to go back to our day one, how we started the journey, understanding from the very basics to till this level. I guess you guys were able to understand or grasp all the 100% knowledge within 30% sessions only. This is the really amazing thing I've seen in my life. People usually takes like more than 100 hours, right? More than 100 to 200 hours to grasp this kind of concept. But really, you guys are really amazing, quick learners. And thanks to you guys, especially some of them were really active. They used to prompt me, they used to tell me or ask me the questions. And that's how this made it very interactive and very successful session. So you guys really, I hope now everyone understand what is the state of art technology, what is ChatGPT, what is generative AI, what is deep learning, what is machine learning. And I hope I am able to give you guys entire go through code walkthrough as well as the entire concepts, right? So you guys will be able to taking it forward, and I wish you good luck for your journey in the AI, guys, and hope to see you soon as a professional AI engineer or ML engineer. Okay. I wish you best of luck, guys, and let's continue this in future whenever we get the time. And special thanks to this FPD program, principal sir, and all the colleagues, because I am not aware who all the colleagues are working in the background. Each and every colleges, professors, whosoever made it successful. Okay, thank you very much, guys, and love you, and see you in next sessions as soon as possible. That's it from my guys, and sign off. We can conclude session, Amar, if you want.
Yeah, thank you so
Anyone
much.
having any question, just I will try to stay back for 2 minutes more. Any other questions, if any other doubts are there, and within 2 minutes, then we'll be finishing this, closing finally. Okay. Okay, guys, if anyone having any doubt, any questions, any comments, please drop me in. I'm still waiting for your comments or any recommendations for 2 more minutes, and then I will be signing off. All right. No, everyone saying no questions. Can we have your session for our students? Yeah, guys, please try to speak with the ExcelR. They will try to arrange. Ujjwala ma'am, especially for you. Because I don't have any contacts, so maybe they can arrange directly then this kind of session.
Yeah, for such query, just drop an email to EDL. Our team will connect with you.
Yeah, please drop. Amar, can you please again share the email ID?
Yeah, I shared in the chat box.
Yeah, okay. Yeah, guys, and I sorry for the earlier PDFs. I will try to upload IPYNB files or code files. Don't worry, I will not upload any PDFs going forward. Thank you for very informative session. Email ID for further discussion. Yeah, guys, email ID is provided in common chat box. You can go through this ExcelR email IDs, and I will be available for you guys. Okay. Re-upload ANN PDF once again. Yeah, guys, I will re-upload all the code. I will upload in IPYNB files again. Okay. Even I will try to give you link for the collabs and the Kaggle notebooks. Okay. So you can directly go to these links and try to access this. Email ID, guys, you will get what on email ID certificates. No other suggestion, any feedback, anything else, guys? Yeah, thank you, guys, for your feedbacks. Any queries? Anything further? I will be not able to unmute you, any of you guys, right? I don't have access, I guess. So just go ahead and tell me.
Yeah, I given the
Sir,
access. Guys, you
feedback,
can unmute yourself.
feedback form, sir.
Feedback. Okay, I'm sharing in the chat box. Team, if anybody wants to talk, I already given you the access to unmute yourself. You can unmute.
Thank you, sir. It was a great opportunity to join this class.
You're welcome.
Ma'am, you can unmute yourself. You can go ahead and speak if you have any query.
Okay, sir. Can you send the feedback link, sir, once again in that?
Yeah,
Oh,
Amar.
yeah, I already shared in the chat box just now. Please check.
Okay. Julia, ma'am, if you have any query, you can unmute yourself and ask directly.
If you want to arrange any session for our students, how we go ahead, sir? On the email ID only we have to send.
Vikas sir and Amar sir, the sessions are really wonderful. We have
Yes,
learned a lot.
Thank
Try
you.
to conduct this and all during Saturday, sir. Maybe in whole day. That is
Yeah, sure, we'll try.
that time we are free. Right now we are working in college, in academics. That's why this is my recommendation.
Okay.
Sure, thank you for feedback, sir.
Nice.
Only the problem was
Sessions are really nice, sir.
Okay. thank you.
Yeah, ma'am, go ahead. Ujjwala, ma'am, you wanted to say
yes,
something?
sir. Yes, sir. The things that you covered was very good, but the only problem was we cannot do simultaneously because the session was too fast to do simultaneously. That's why we require the hands-on practice also for that. Then in the end, most of the doubts will be clear. Most
Yeah,
of the
so
things were new.
yeah, okay. I understood. What you can do is I am sharing all the codes and link everything. You can practice this easily on Kaggle and Collab.
And still, I have the problem with chatbot. We cannot purchase that thing, and
Yeah,
that's
I
why.
will. Yeah. Okay, I will upload entire video,
Yeah.
step-by-step video along with the instruction set. That I will do from my side.
Because we can give these projects to our student, they will explore the things right away.
Yeah, great. I will upload entire video tutorial how directly from the Google. I will try to
Yeah.
upload that. I will try to share with the team. They will upload on the LMS portal.
Okay.
Google side.
Thanks a lot, sir.
Yeah, okay. Thank you, ma'am.
Sir, good evening, sir.
Good evening. Go ahead.
Sir, my request is,
Huh?
suppose if the people.
एक मिनट.
Hello.
Yeah, sir. Jagdish, sir, go ahead, please.
Yeah, sir. If the people knows something about the machine learning and all, they can do it. But for the beginners, can you take the project kind of thing based on some problem? So in a sequence way, in a proper sequence, if you take the session, it would be better, sir. Now it is okay, sir. What you have taught us from the 15 days, it was very nice. But to gain the knowledge of how to do the projects and all, how to initiate, for that some idea is required. For that, can you take some initiation to proceed with that?
Okay. I understood what you are saying. You are saying that please take session in such a way that will be project focused, right from day one.
Yeah, exactly, sir.
And how we can write code, anything, how we can start doing anything.
Yeah, sir. Yes. Related to even data set also. So like you can tell the participants to give the inputs like for the particular problem, what data set should be taken, what all the parameters should be there in that, and what all that should be taken from it should be asked to the participant, and let them do involve. It will be like a hands-on.
Yeah, understood. So that is possible from machine learning point of view, where we'll not require any kind of hardware. But for
Yes,
deep
sir.
learning point of view, then I will be only one who will be able to explain, and they can follow the things line by line at that time possible. So it is possible in machine learning. What we can do is I can create a different use cases with real-time examples, and then I will try to assign this to them, and they will try to build up model. At that time, I will take entire all the algorithms line by line, how to build a single line, how to do EDA, how to import the data, how to clean the data, how to present the graphs, and then how to build the model. This way.
Yes, sir. Absolutely, sir. Yes, sir. Yes, sir.
So
Yes, sir.
how
Thank
this
you, sir.
thing can be happen?
Yes, ma'am, you're saying something?
Yeah. You were saying that you can do everything starting from scratch to build a project for students.
Yeah,
But
okay.
how the things will happen?
Through this kind of program only, FDP program, we'll try to arrange this kind of session once the request comes in from your side.
When request is you specially conduct the program for student. Now the session is just started and every student is searching for project. So if they get the better idea, it will be better for them. And especially the students belonging to the AIML branch.
Okay. So my team will try to get in contact with you. Amar, please take a note of this, and respective person can speak to this ma'am directly and try to understand all the requirements so we can accordingly plan a sessions.
Yeah,
Yeah.
sure. We'll connect with Ujjwal, ma'am, definitely.
Yeah.
Thank
Please
you.
connect with her so we can understand entire requirement and we can arrange the session accordingly.
Thank you, sir.
Sir, my requirement is also same. I am the head of department of CSCAI
Okay.
from Presidential College of Engineering.
Uh-huh.
So we'll require the project ideas for the students also.
Okay. Then my team will also speak to you guys then. Amar, take also note of this, ma'am.
Oh, yeah, sure. Vijaya, ma'am, right?
Yes, Dr. Vijaya Balpande.
Okay, sure.
Yes. And sir, your sessions were really good. Some of the time I could not make it because of the meeting and all.
Okay.
But whatever the things I have heard, it has been very interesting. And we have got a lot of knowledge from your side.
Okay. Thanks, ma'am. Thanks for the feedback. It is really a pleasure because whenever we try to conduct this kind of session, the entire motto is that not to make it very complex, but make it in such a way that people will be able to understand all end-to-end things. So that's why
Amar, one more request is there. To type a message and give the question requires more time. So next time you please conduct 5 minutes online session
Yeah,
by
so,
unmuting us.
yeah, definitely.
Because the moment we type the things and the session is closed at the end. Many
Okay, in
times
last
happens
10
this.
minutes, we'll give the access to unmute yourself, definitely.
Yeah, like today, give the access to every day so that we can talk to Vikas sir one-to-one.
Yeah, definitely.
Yeah, good suggestion. Yeah, we can take into consideration this thing.
And Amar sir, it is like I have the LMS of yours, but the previous videos are not being accessible in that.
Okay, so we'll check from back and just share your email ID with me.
Okay. Fine.
Yeah.
Sir, how much day we have access of that LMS?
It's for lifetime.
Okay, thank you, sir. Thank you.
But the videos are not being available now. Whenever I've gone through now, so it is not being available.
No, videos are there. In
Videos
the
are there.
app, videos are there.
Videos are there, ma'am.
Videos are not working, but
Actually, it's take a time to load. Still, we'll check from the back end.
Okay, fine.
For others, it's available. I hope.
Yeah, I'm talking about the previous programs.
Okay. We'll check, ma'am. Don't worry.
Okay, fine. Thank you.
Yeah, welcome. Team, anything else? Anybody wants to talk?
Thanks a lot. I will keep in touch with that same ID. I think will be available, no, Samar sir? EDL.
Thank you, Vilasini, ma'am.
Thank you. All right. Anyone else would like to add anything?
Suppose we want to keep some actually the session for our students.
Ma'am, actually, sorry to disturb you, but your voice is too low. Can you please be a little bit louder?
Okay. Can you hear me now?
Yes, but low actually.
Somewhat better, but can you try to speak a bit louder?
Oh, right. Now?
Now it is okay.
No, I think suppose the actual ingredients, if at all we want to keep for our students the session, how can we go ahead?
Okay, keeping a session for the students.
Yeah, artificial intelligence. Yeah.
Yeah. Okay. So my team will get in contact with you.
Okay. That is okay. Viren sir, no?
Yeah.
Vikas sir. Sorry, Vikas. I'm sorry.
Yeah, Vikas here, but my team members will get in contact with you, the backend team members. So Amar, please also take a note of Vilasini, ma'am.
Yeah, sure.
All right, again, guys. Thank you very much once again. Then I will conclude if no further questions.
Thank you, sir. Thanks a lot. Thank you.
Thank you, guys, and it was wonderful. and hope to see you again in coming session.
Sure.
Thank you very much, guys. Then I will sign off then. Okay.
Okay, thank you, sir.
Bye bye. Have a good week ahead, guys. Bye.
Bye, sir.